Once we've completed our work on the prototype and we have a selected option, we'll move on to refine the model. And what we'll do is we'll start adding a considerable level of detail to the model, which ultimately will allow us to coordinate with the contractor and construct the project, to build the building from the model or from the documents developed from the model. So you can see here now that we've jumped back into the Revit model that we've progressed the model along fairly well. But if we zoom in here a little bit, we can see that we have not only the architectural elements in place, we've defined a lot of the wall elements and features and doors and such. We've also incorporated the structural content framing for this main north-south canopy element. And if we look in here on the roof area, we can see that we have rooftop equipment. And if we zoom in a little bit farther and actually kind of tilt the model a little bit, we can zoom in, and we've turned off the roof surfaces and some of the ceiling surfaces just for clarification's sake, but you can see that we've modeled some of the mechanical work as well, the ducts and diffusers and some of the primary piping components. And this is important because as we're coordinating the various systems in the project, we want to make sure that obviously if you have a light fixture in a location, you also would not want to have a mechanical diffuser or a sprinkler head in that same location. A lot of times we will also move to control some of the visibility settings in the project. So for instance, if I want to see some of the detail coordination information within this south building model element, but I don't necessarily need to see the entire project, what I'll do is I'll come in and I'll take a 3D view and I'll slice it based on the parameters of a 2D section view. And when I do that and I come in and I zoom in here a little bit, I'll be able to see in a little bit better detail and better clarity the coordination between the electrical systems and the mechanical systems, structural and architectural. And if I start to tilt and rotate this just a little bit, we can start to see some of the richness of the information involved in this. And this is very useful. This is very effective in coordinating, not only between the various architecture and engineering disciplines, but it also helps a great deal in communicating information to the contractor. So you can see in this model that we've developed a fair amount of content in the restrooms, and you can see light fixtures overhead and how this all lays in and works together. And some other useful features are here. This is an area where we're doing a study for some solar panels to be located on the roof, and we wanted to coordinate exactly where are this is a mechanical lever that operates a blade within the mechanical ductwork, and it's important to know where this lever is located, where the light fixture is located, and where one of the ceiling tiles could be opened up so that for maintenance purposes someone can get up and access this lever and manipulate the controls as needed to make the mechanical system function properly. So again, showing layout of the brake work, of the casework in the brake room. And in addition to coordinating the technical systems, we can also utilize the model to do some studies on exactly what is the lighting going to be like, how are the materials and finishes going to look when the project is complete. Here is an example of, we were doing some different studies and different types and finishes and textures of the glazing. And we're just looking at the same component and just changing out some of the panels and variabilities. Again, looking at some of the spandrel panel configurations here. This is looking at the south building. And we're just doing some very basic studies. They're fundamental, but they're critical to the success of the project, of getting a good understanding of how the different materials and finishes are going to work together.